Alright, learning outcome B8, talking about acids and bases and pH. So pH, I'm sure you've all heard of that. It actually is it's just a single number. There's no units associated with it. And it represents essentially the hydrogen ion concentration in a solution. Or a mixture, or what have you, in a liquid, or anything. If you take a look at this picture here, this is the pH scale. It goes from 0 to 14, with 0 being the most acidic, and 14 being the least acidic, and the number 7 being neutral. Now, you've heard of the term acids and bases. Something that is less than 7 is said to be on the acidic side. Something that's greater than 7 is said to be on the basic side. So something that's very basic, let's say bleach, has a pH of 9.5, has a very much higher hydrogen ion concentration than, let's say, wine or vinegar, which has a much lower hydrogen ion concentration. Now, students usually get confused on this because they think, well, the higher the number should mean more acid. Well, it doesn't. And that has to do with the way that you calculate the pH. And I don't want to get into all the chemistry behind that, but you just have to learn and understand that the lower the number, the more acidic it is. The higher the number, the less acidic. And 7 is neutral. So, for example, bananas are less acidic than lemons. Or coffee is more acidic than milk and has a smaller number. Okay? Now, if we said that we decrease the pH, are we making something more acidic or more basic? We're making it more acidic. So if I said the pH increased, are we making something more acidic or more basic? It's becoming more basic or less acidic. Okay? We're making it a bigger number. Now, let's compare numbers. If we were to compare something of a pH of 3 to a pH of 4, how many times stronger is something with a pH of 3 than pH of 4? Now, it's not one time, it's actually 10 times. The pH scale works much like the Richter scale that measures earthquakes. You know, a 10 on the Richter scale is a super massive earthquake. When you compare that to an earthquake that is a 3 on the Richter scale, it's very weak. But from 3 to 4 on the Richter scale, a 4 is 10 times as strong as an earthquake that was a 3. In the case of pH, of course the numbers go backwards, a pH of 3 is 10 times more acidic than something of pH of 4. We could also say that in the reverse, that a pH of 4 is 10 times less acidic than something of pH of 3. Alright, what if we went from pH from 3 to pH from 5? How many times more acidic is pH 3 than pH 5? Well, 3 to 4 is 10. 4 to 5 is another 10. Whoops. So a pH of 3 is 100 times more acidic than something that is a pH of 5. Or we could also say it's 100 pH of 5 is 100 times less acidic than something that's a pH of 3. Now, why do we talk about pH? Well, body, blood, and solution pH in the body is very important. There's a very small window for pH in the body, and the pH range of the body is 7.35 to 7.45. That is the basic range. So is that on the slightly acidic or slightly basic side? If you said slightly basic, you're correct. So if this is 7.3, we're looking at right in here. But there's a very small window. In order for enzymes to function properly, for chemical reactions to occur in the right way, in the correct way, and to maintain proper body homeostasis, this is really the only range. There is really not a big window in pH. Now, there are things that we call buffers. And buffers are things that help to balance pH or help to keep pH within a certain window. And we have both physiological and chemical buffers. Physiological buffers would be various processes that are working to keep the pH within a certain balance. For example, when your blood pH drops, your body can change your breathing rate to change the amount of carbon dioxide in your blood and thereby adjust the pH back to within that window. That's a physiological buffer. Chemical buffers would be chemicals that your body is releasing or using, or things that you're physically consuming that are helping to balance your pH. Let's say you have heartburn. You can take Tums or Rolaids or Pepto-Bismol or something. Those are buffers that are helping to neutralize the acidity of the stomach that's splashing up on your esophagus, and that's helping to neutralize that pH. There's chemical buffers in the body, which include bicarbonate ions, different phosphates, and various proteins as well. These all act as buffers in certain ways to help make sure that blood pH and body pH stays within the proper window. And as we go through the different chapters and the different systems, I'll address these as they become relevant.